untitled, so now I have to use my finger. With the stylus thing? No, I can't. I can't write with my finger. It's driving me crazy. Looks like I'll be taking pictures of TV. You write with your finger and it doesn't bother you.
Hey, Dr. Riley. Dr. Riley?
Yep.
Thank you for suggesting the quadratic formula. I would not have even got any the problems done without that. But my homework, the homework isn't exactly done. Do you want me to just send you what I have anyway?
Yeah, that's totally fine. Totally fine.
Okay. Just as long as I know what I'm doing.
Okay, good.
I would get an hour.
Okay, so I don't have COVID.
So I don't have a math tutor.
I have Caitlin, yes, I do. And I have.
Yeah, we've done a lot more since then.
Yeah.
After break, I just was so over school. Yeah, me too. I don't know how I'm gonna have to fund it. It's just what is the next one? Those are just mine. We already know where we're going and we're in. So it's here. Wait, did you commit yet?
Alex is here on Zoom. Alex is here on Zoom. Alex is here on Zoom. Dave's here in person.
Do you know like where you want to go?
Okay, so this is Dovey. No, I have Dovey. Okay, that's it. There we go. Show my guys. Okay. Here, present on Zoom. And Cody's present. Okay, so welcome back. Let me just get Dovey in. So today's going to be a big kind of work day, pulling this together for 2.3. So what did I say? Okay, I just put all the attendance in, so that's all good. So on page 7, over here. Okay, hold on. So what I said was that we're gonna spend today working on the rest of this homework sheet and the 2.3 homework. We're gonna go over that now. We're gonna have a quiz on this, not next class, but in 2 classes. So I wanna make sure that we're having a good handle on what we're doing. Okay, so I know I had emails from people about the 1 through 6. So let's go over some of that now. So then Marina, the question we were working on together, we did quadratic formula, whereas I was able to factor everything. So I need to go back and look at that. So maybe.
Whoops. Dang, it's probably me. I probably just thought it wasn't factorable. Oh well.
So let me see, can I grab yours so I can see what we were doing? That made me think that it had to be factored by quadratic. So let me just grab that. Okay, so it looks to me that I have a ton of people that don't have anything turned in. And I mean a ton of people. So what's up with that? Am I losing my head here?
Where are we supposed to turn it in? Because I didn't see one that was due today. Or like, I didn't see anywhere to turn in the homework today.
Okay, so it's the 2.3 should have been due today, so hold on. Yeah, the 2.3, so where it says January 13th. So not where it says new assignment. If you go to classwork, the January 13th, Wednesday 2.3. You go there, what is the instruction? No, that's not it. So let me go back. Hold on. Hold on. Yes, I posted it on Wednesday, so it should be due then. Did you not post it because there's no due date on that? I have lots of people posting it. So, what do we do about that? So my question is, did you work on it? So like,
Oh, yeah. Do we just post it on the Wednesday one? Like the one that's due next Wednesday?
yeah, post it on the Wednesday where it says January 13th.
Oh, okay. Thank you.
That was the assignment.
That's where you want to post the homework?
Do problems 1 to 6 only on 2.3. So you always post it where the homework assignment is. So post it on the January 13th. I did not put a date on it, so I will fix that now, I guess. But that was the homework. according to that assignment. So it's due today, but you should put it on the 13th because that's the day it was assigned. I think we have a chance to do that while I just look at some of these so that I can figure out how to help support what we're doing. Oh, Marina, I found it. No wonder our numbers were so goofy. It's your first derivative shouldn't have the 1 in it for the first problem. So I think I never looked up, I just worked with your derivatives. So that's what it is. Okay, so today's our big fine-tuning day. So I'm trying to figure out if I want to work with someone's paper or just do it myself.
Dr. Ryder,
Mm-hmm.
do you have any like scrap paper or anything?
Yes, I should have some in the back here. Yes, I do.
My stylus, so I'll just like.
Oh, yeah, and, no, my computer, right, to hold it down. Uh-huh. There's more in the math room. Okay, so let's do this. I will check that assignment later. But I'm inclined to just do a clean copy for you. Okay, so let me do that. Let me just see if I have it in my Notability already. If not, I will put a clean copy up and then we will talk about that as we go. Okay, so I need to put a clean copy up. Let me do that.
Wait, Dr. Ryder,
Mhm.
are we learning anything new today or is this
No,
just like?
it's a work day.
Okay.
Yeah, we have to spend time doing this. What did you all learn? Did that help?
Oh, no, I was
Or
just
change it?
wondering, because I actually got like what we're learning, so.
Okay, because you didn't do the whole package yet, though, right?
Me?
Uh-huh.
No.
So that's what I want people to be able to sit and work on it. Okay, so I'm in Notability now. Okay, so I'm gonna call on you for this, some of these things. So that means that you need to be available by Zoom if you're on Zoom. Okay, so let me share this screen and I'll just show you what I think is a good setup. And since everything depends on your derivative, you definitely want to go back and make sure that all that is good and that first off, you copy things correctly, because sometimes that alone can put you in a bad spot. Okay, so this is the very first problem. So I have some things I noticed right away. I'm noticing that it's a cubic. So therefore, it's going to have probably a max and a min, and it may have an inflection point. So I kind of know that going into it now. So take your first derivative. So Marina, this is the step I told that we had a problem with. Take your first derivative, and it's going to be 3x squared plus 12x, but no 1. So Marina, you see that? Get rid of that 1. Okay, so then set this puppy equal to 0. Okay, you can do greatest common factor factoring. That is the most neglected type of factoring ever. So you can factor out a 3 and an x, and that gives you x plus 4. So therefore, in job, you see that? So don't do anything fancy with this in terms of quadratic formula. So this one, just factor out the greatest common factor. Okay? Okay, so I end up with 2 critical values. My critical values are going to be set 3x equal to 0, and you get x is 0. Set x plus 4 equal to 0, and you get negative 4. Okay, any issues with just getting critical values? And so for these, I will tell you, some of them are fractions, some things are fractions, but I don't think, I did not use the quadratic formula for anything because it was unfactorable. Now, if you get stuck on a factoring, there's no reason why you can't use the quadratic formula. I recommend it because there's no sense in waiting a long time to get it factored if you know that your work really begins after factoring. Okay, so I have a critical value. So take your critical value and plug each one into the original formula. Okay, so the original formula. So therefore your critical points, if I plug 0 in, I get 0, 1. If I plug in -4, I get 33. So those are my critical points. Okay, so I'm going to keep working on whatever I need to work on here. I'm going to now get my second derivative, which is going to be 6x plus 12. Set that equal to 0 to get your inflection point. And that's going to be x equals -2. Plug the -2 into the original formula, and you get -2 comma 17. Okay, so I have everything I need right now. So I'm going to stop there. So this is the first problem. How are we doing on this? So Audrey, did you get any of this stuff started? Because I know you were out there today. I sent you the video.
Yeah, I watched the video and I got like a majority of it. I just did the factoring a little wrong.
Okay. All right. And then let's see, I'm just gonna hop around. Jalen, how are you doing with this? Okay, I guess I'll hop around in here. Billy, how are you doing with this? Did you get what I got so far?
Yeah, I get confused on the kind of the sign chart.
Okay, we're gonna do that now. Okay, so let's do the sign chart, because I saw in my other class, people are doing the sign charts all kinds of different ways, so let's be consistent. It's like a number line, and therefore, the -4 is gonna come first, and then the 0 will come. Okay, those were x values, so put an x right there. I'm now going to evaluate them using a first derivative test only. So what I'm gonna do is I'm gonna test a number less than -4. So let's test like -5. And where do I test it? I test it over here. Okay, test here. Because you want to test what the slope is. So take your -5, and -5 times 3 is -15. And then if I put a -5 in here, I have -5 plus 1, also negative. Negative times negative is a positive. So I know my sign's positive there, okay?
Yeah.
Okay, so then pick a number between -1 and 0. So let me erase what I had right here. Whoops, I'm going to erase my 3. Okay, erase what I have right there, and let's plug in a -1. So if I put a -1 here, I get a -3, and then -1 gives me a positive 3. A negative times a positive is a negative. It doesn't matter what the value is, what matters is the sign. Then pick a number to the right of 0. I'm going to pick 1. Plugging 1 in, I get a positive 3 here, and I get a positive 5 here. 5 times 3 is a positive. Therefore, this is positive. Okay, those are my slope values. Now, down below here, don't do it above, do it below. This is going to be your function with your maxes and your mins. So because it's going from positive slope to negative, I know that it has to go like this. Then it's going from negative to positive. That's what's happening. Okay?
Yeah.
Okay, so now this doesn't ask for a second derivative test, but just for clarification, we're going to do one. When you do a second derivative test, you test right on top of the critical value. And what you're doing is you're testing the concavity. So you take that -4 and you're gonna plug it in here. Okay, so 6 times a -4 is a -24 plus the 12 will still give you a negative number. Therefore, my concavity is negative, which is concave down, which affirms what I just figured out by looking at the slopes. So those things match. Okay, so then do the same thing with the 0. Plug the 0 in, 0 times 6, 0. I have 12 left over, that's a positive. That tells me that it is concave up, which affirms what I just figured out. Okay, so those are your tests. Now, you can never have a chart without a statement. So your statement's gonna be, I'm just gonna do the first derivative test, because that's all that was required here. So you would say that at the critical value of -4, the slope, M stands for slope, changes, that stands for changes, from positive to negative, and that gives me a max. As opposed to the CV of 0, the slope changes from negative to positive, and that gives me a min. Okay, so the chart and your statement have got to go hand in hand as one unit. Okay, so this is one unit. When they ask you to do a sign chart and make a statement, this is what that means. Now you have to graph your picture.
Dr. Levy, I have like a quick question.
Yeah,
So where you got like -2 at the top for the second derivative, where do you plug in the -2 at to get the 17?
back in the original function.
Okay, just one.
Good question. Okay, so whenever you want to get a y value for all of these points, whether it be inflection point, which is this one, or the critical point, take that x value and plug it back into your original function way up here. Okay, make a big note about that, because I'll tell you, that's the #1 problem people have. So now I'm going to graph my points. So I know that my y-intercept is at +1, because that's the original function. Then I have the critical points, 0, 1, and that's going to be a min. So what I'm going to do is kind of put a little smiley face on it until I sketch it. And then I'm going to have -4, 33. So let's just say that this is 33. So these are sketches, they're not graphs. Okay, they are sketches. So they're not going to be as exact. Okay, that's going to be a max. So I'm going to put a little max thing there. Then I have an inflection point at 2, 17. So let's say that's right about there. Okay, so here comes my sketch. Okay, done. I have the max, I have the min, I have the inflection point. Okay, and the y-intercept happens to be where the minimum is. Okay, so I've got that one. Okay, so I don't want to go through all of these. So I like to see what people have on theirs. So I'm gonna get out of this for a second. But first I'm gonna say, anybody have any questions about this? So Jock, does this make a little bit more sense what I'm doing?
Yeah.
Okay, good. And Marita, do you see where we went awry?
Yes.
Okay. All right, so let me, Audrey, I know you were out, what do you think?
Yeah, it makes a lot more sense, like seeing it visually.
All right, good. Good. Okay, so I'm just gonna close out of mine, and maybe I'll grab somebody else's, and we'll see what we want to discuss with theirs. So I might have to unshare and reshare. but we'll see. So let me get in here. Okay, so I'm just gonna work my way down. So Alex, this is yours. So you need, you have your sign chart, and then you have your statement that goes with it, good. Okay, so number two, when I factored it, I agree, I got that from my factors. Let me just get my pen so I can make any kind of marks I want on here. Okay, so I agree with your factors, and then I also got negative 1/2 and a third. Okay, so look at your work, you should be getting a third and negative 1/2 for your critical values. Then your chart should look like Alex's. That is good. Negative, positive, negative. So then what you find is that when you graph it, you are below the x-axis. I also always find the inflection point. So let me see, I don't see an inflection point. Let me just do that for you. So always find the inflection point, even if you're not doing a second derivative test, because that gives you another point to graph. So this is what I get for my second derivative. So negative 36x equals 3. So x is going to equal negative 1/12. So I don't think I got the y value, but I got the x value, so I knew when things were turning. You could have put that in your graphing calculator and gotten the y value too. So this is the x of the inflection point. Okay, so that gives you an idea how things are turning. And it was at negative 1/12. So it makes sense with his sketch, right about here is going to be your inflection point. Okay, so that was good. So I'm going to save that for him, and we'll go down, I'll find another one. Okay, anybody have any questions on that second problem?
Can you go back to it for a second? Because I did something wrong, so I just want to copy it down.
So, here it is, it didn't say my comments, but it's all good. I'm sorry, I'm going to come back to it in just a sec. Okay, so here's the second one. Right there. So sign chart and critical values are all good. Now, the other thing I like that Alex is doing, do you see how he is right here saying to get that value, I'm going to plug it in the original function? That will keep you honest the whole time, because the biggest problem is trying to plug this in. If you plug the 1/3 into your first derivative, you'll get 0. So you're going to have 1/3 comma 0 and negative 1/2 comma 0, which doesn't make any sense. So you definitely want to be plugging it in the original function. Okay? So is that okay? Can I move on to the next one? So those first two are in the bank. Now we have another one. And so for that, I'm going to get out of Alex's. Day had you do?
2.
What?
2.
Okay, well, I'll have to write then. That's okay. We're going to fix that. Okay, so let's see what's going on here. This doesn't look terrible. How would you say terrible? It looks very nice. Okay, so first derivative is good. I'm trying to figure out where it is. So here's your first derivative. So notation, especially for this day, because it's going to mess you up if you don't know what it is you're looking at. So get your first derivative. I like your critical values, negative 1/2, positive 1/2. So I agree that it goes positive, negative, positive. So once you see that, then go ahead and do this little thing for yourself. Okay, so if you wanted to calculate the second derivative, it would be 8x. So that means that you would set this equal to 0. So your inflection point is going to be the y-intercept, because it's going to be 0, 2. Just remember, to get my y value, I plug it back into the original function. So 0, 2 is an inflection point. So so I'll probably draw this just a little bit different. So if you have your grid, and say this is -1 and this is 1, so 1/2 is going to be there and there, say. So I know that I need to have, let's see, 1/2, and I have 2 1/3. So 1, 2, 3. So 1/2 and 2 1/3, -1/2 and 2 1/3. So that's a point. And then at 0, 2, here's my inflection point, also my y-intercept. And then at 1, 2.3 right here, that's my minimum. So given that, I'm going to go like this, go to the minimum and come up. Okay, so you want to be able to isolate, that's a max, here's the minimum. And then you're all beautiful, okay? So then, the only thing is make sure you have a statement. So at the critical value of -1/2, the slope changes from positive to negative. Therefore, I have a max at critical value of positive 1/2. The slope changes from negative to positive, and therefore I have a min. Okay, any issues with that? Because that was not too bad in terms of the factors and getting the graph done. The numbers kind of are okay. Okay, Gracie, how you doing with this? Okay, so thank you, Alice. I got your message. Okay, so I'm assuming everyone's okay with that. I'm saving that for you so you have it in your Google Classroom. Okay, so now we have vocab. Okay, you need to know this vocab because this is what you're doing. So let me go around and let's ask. What does the first derivative test analyze? It was a basic thing. It's not a long explanation. What's the one thing the first derivative test is looking at? So Lauren, what do you think? So it's looking at, does it test where the function is increasing and decreasing, or does it test something else? I can hear you.
Where your critical points are.
So I would say it's just testing slope, right? Because that's what you're evaluating. You're saying, okay, what is the slope at these different places? So number one thing, in terms of vocab, when you talk about what does the first derivative test, you are looking at slope. So if you don't have that down, write that down. Okay, so given that that's my idea for the first derivative, what's the second derivative analyzing? Yes?
It tells us the graph's concavity.
Yes, exactly.
And I think it's interception point, whatever the.
Inflection point?
Yeah, inflections.
Yeah, but what it's analyzing is the concavity.
Yeah.
And at the inflection point, what's the concavity? Nothing, right? It's changing. Just like at the max and min, what's the slope? It's 0, right? It's neither up nor down. It's not increasing, not decreasing. So just keep those two straight. Okay, so then what's a critical point? So a critical point could end up being a blank, or a blank. Fill in the blanks. Anybody at home, Colby? An extremum or a critical point can be a blank, or a blank.
The critical point is the x value from the first derivative, isn't it?
Well, that's the critical value. The critical point is a coordinate pair. And it is with
Oh,
the
the
first 0. And where it equals 0, you can have a blank, or a blank. The first two words start with the letter M.
Is it maximum, minimum, and shelf?
Yes, that's it. Okay, so maximum, minimum, and shelf. Okay, and the last thing Billy really has, Billy, what is an inflection point? It's the point where what changes?
I said is a point on a plane where the curvature changes depending on the inflection. I'm not sure if that's right.
Just say it's the point where the concavity changes,
Okay.
right? So it goes from concave up to concave down, or concave down to concave up. And if there isn't one, then that means that particular function has only one concavity throughout.
Alright.
Okay? All right, so how are we in the vocab? Is that good? Okay, this would be a whole lot more fun if you were all here with me. Because we'd be at the board doing this, it's a lot more fun. Okay, especially last period Friday, this is tough for everybody. Okay, so the last two questions, I did want you to use the first and second derivative test. So that means that you want to have your sign chart also have testing above the critical values for the second derivative. Okay, that'll always help you graph anyway, but this one I asked you for. So let me, I'm going to stop sharing for a second so I can reshare. So let's see how this went. Okay, anybody overly confident with their work that we can look at?
I think mine's right.
Good. Lauren, okay, good. No, good.
No, that
Okay,
was Madison.
Madison. Oh, it's you? Yeah, okay. So hard to tell where the voices are coming from. Okay, so got Madison up. We're gonna look at number 5. And I'm gonna share screen now. Okay, so number 5, we're gonna go to, like the blue colors. Okay, so here we have it. So when we're doing this, we start out, so I don't think, so you can put your, so you're not gonna do, so this is great, because you are talking about concavity, but what I'm gonna have you do, you can leave that totally fine. But then I would say, let me just get this back. I would say, right on top of your, yeah, I see you're tying the negatives together. So right on top of your critical values, write what your second derivative is. So it's negative, and therefore you are concave down there, and this is positive, so you are concave up there. So that's the only comment I would make, that this first line, the plus, minus, plus, is all correct, and that line is your f of x. Then like prime of x. Then your next one is going to be your f prime of x, and that's where you have the faces. And then down below, what you can do is give yourself an idea how things are going to go. Okay, and then down here is going to be your f of x. Okay, so I agree with everything that you have here. So what's happening is then she has a statement. Okay, so why are you saying the graph's increasing? So we've already talked about what. So don't do graph. Instead, for your statement, say at the critical value of 0, the slope is changing, right? So the slope changes from positive to negative, and therefore we have a max. So when you do a first derivative test, you've got to discuss your slope. Okay, so then at the critical value of 6, the slope changes from negative to positive, and therefore that gives you a min. Okay, so this is your statement here about your sign chart. Then you need a little statement about your second derivative. So in terms of your second derivative, what you would say is that the critical value of 0, f prime of 0 is negative, so therefore it's concave down, and that gives you a max. Okay, at the critical value of 6, the f prime prime 6 is greater than 0. So it's concave up, and that gives you a min. So the word concavity has to be in your second derivative statement, and the word slope has to be in your first derivative statement. So Max has a good sketch here, because here's her max, here's her inflection point, and here's her min. So it all looks good.
Dr. Riley.
Uh-huh.
Can I go to the bathroom?
Uh-huh.
Thank you.
So then we have one more to do down here, and it's number 6. So I'm going to save this for Madison, and I'm going to grab another one. Rita, I'm going to go to you. So let's get a pen.
I think I graphed it wrong, but
I'll just fix it on it for you, so it's all good. Okay, so this is, yeah, so this is 6. And so for 6, I agree that you've got -3 and 3. And I agree with all your information. So let's see. So you've got the critical value, the slope does not change. Okay, so did I get them? No, I didn't get that. So I got, this was negative, this was positive, and this was negative. So let's see why I'm doing that. Okay, so if I take a -4 and I plug it in my first derivative, that's a -16, say, plus 9, that's negative. So we agree there. If I plug in a 0 in my first derivative, I get 9. So how are you getting a negative for that? Did you plug in the original function?
I think I did. Yep, that's probably what I did.
This is going to be a positive here. Then if you put a 4 in, so if you put a positive 4 in, you're still going to get the same result you got when you put a -4 in because you squared it. So this is going to be a negative. So that's what impacted your sketching. So then this would have been going this way and then going that way. Okay, and then your inflection point should be at 0, -2, which you have. All right, so I'm okay there. 0, -2 is good. So then the difference is up here, so you just have to follow your points. Because here's your -3, -20, which is your min. And then you're saying that your max is 316. So it has to be up here. So that means that your shape would go through the inflection point and up here. And then you're all good. Okay? So that's good. So that's what you have. So remember that what your statement, you need to have a statement that involves slope for your first derivative test and a statement that involves concavity for your second derivative test. Okay, so that's it. So what your job is the rest of this time is to continue working in this packet. And you don't have much left. So we have what, 7 and 8. And then do I have anything else beyond that? And that's it, I think. So you should be pretty good to go. And that would be the homework, but you can do it right now. See what happened there. Okay, so I'm gonna just let you work. See if you can, if you need to, you know who needs to go over things, so go over things if you need to, on what we just did. And then you're good. So I was thinking that we'd have a quiz on this in 2 classes, so not the next class, because we have so much time off in between, but the class without, after that. So when I say don't use a graphing calculator, so there's no way that I can reach through the screen and see who's using a graphing calculator. So the thing is, you want to be able to graph this independent of a graphing calculator, which means that you have to justify how you have the points you have. Okay, so to get your y values, I'm totally fine with using a calculator. This isn't a math class. I want you to figure out, it's not an arithmetic class. So use it to definitely get you y values, but then you need to justify your shape by your first and second derivative test, okay? So that's what I'm gonna say. Okay, so go ahead and work on 7 and 8, and we will call it a pretty early day. Then I'm here to help anybody that needs help with any of the previous stuff, because I'll do some more stuff on this next class, and then I'll probably start teaching a little bit of the 2-4, and then we're gonna have a quiz, the very next class. Okey-doke, let's see what we have. Yeah, I have some extra material that we're gonna work on next class that will be the same topic. And then we'll just review some more, do some more practice problems, and then you'll be ready for a quiz. Uh-huh.
For 9 and 10, how do you go about figuring out which one's the derivative?
So for, 9 and 10, I didn't print out. No wonder I was doing that. It was easy. So what does 9 and 10 say for second derivative test?
No, they the graphs, and you have to figure out which one's the derivative of the other.
Oh, yeah. Okay, let me get it. I think I printed it out in the other office. And let me just grab it. Yeah, so that's really cool. I love that one.
Yeah.
So, okay, so where you start is, you're gonna look and you're gonna say, where is the flat section of the curve, let's see. So I see I have a root, I have a root here, right? Is that under a vertex? Then I have a root here, is that over a vertex? So since that value is 0, that's the derivative. Yeah.
But how do you?
So you would say that, so this is your y, that's actually going to be f prime of x. So your g of x is really f prime of x in the little box. So just say that your g of x is equivalent or equals f prime of x.
I have a question. So I did number 7 already,
Uh-huh.
but I don't know how you do 8, 9, or 10.
Okay. So let's see, so 8, so it says, what was the population in 1925? So I look at my graph and I see that this is population, this is change in population, and this is rate of change in population. So if you want the population, you're gonna look here. And 1925, that's 1800, that's 1900, and that's 1925 right there. So you just read over it.
Oh, so
Okay.
that would be,
125 million? 125 million. Am I reading it correctly?
population. So this is in millions? Or
So it
this
says the
is-
population in millions. So this is the date, but they all start at 1800. So that means that this is 1850. And this is 1900. And this is 1950. So you want 1925, right? So that's gonna be here, go up and over, and it's gonna be 125, and populations in millions.
So 125 million. Okay, thank you.
Yep, you're welcome. Let me just get my other hand out. Okay, I have to print mine, that last page. I don't have that last page. Let me do that.
What did you say the red and green lines were again?
So the red line is your first derivative, and the green is your second derivative. See, it says, so your first derivative is your rate of change. And your second derivative is the change of the rate of change.
Okay.
How's that for giving you a headache on Friday?
How fast? So when it says how fast was the population growing in 1950?
That's a rate of change.
So I look at the red.
Yes.
Okay.
And when they say what is it growing at the greatest rate? Let's see, the greatest rate is going to be the steepest part of the original function, right? That's the greatest rate. So that steepest part is going to be the max of your red curve. But you can also read it as the zero value of your green curve, because they're really asking you for the inflection point.
So like for E it would be like 3 million. It's the max.
In what year? So it's when, let's see, in what year was population growth greatest rate? So it's going to be, no, it's going to be 140 plus 1800, so 1940.
Oh, what year?
Yes,
Sorry.
what year?
And then what about for like C and D? For C, you would use the red one, right?
Right, because how fast is the rate of change growing? So fast is a shortcut to say derivative. Oh, I just don't have 2 pages. Okay, so I need. And 7.
So how would you find the derivative like on the chart? Because I know 1950 would be where the 150 is, right?
So how fast, right, exactly. So how fast is that? So just go up to 150 and then read the slope,
Oh,
right? So it's going to be 1, 2, 3, 4, 5. Everything is 2/10. So the rate of change should be 2.2 million people per year, if it's 2.2, right?
yeah.
Yes, that's how you do that. Let me just write my 2 other pages so I can all be on the same page with you guys.
Do it, D. Did you get D?
I said 1910.
I don't get how you read this. Like, I don't understand.
When I did on the last degree, this is the population line of the rate of two.
Today, how do you keep your sneakers that white?
Hmm?
How do you keep your sneakers that white?
I was gonna ask you that.
Oh, no, I clean up.
Did you use that white shoe polish on them? That'll do it. Back in the day, nurses used to have to put the white shoe polish on their shoes. Any white? I don't even know if they make that white shoe polish anymore. Okay, how's everyone doing at home?
Can you use the bathroom?
Yep, go ahead.
Dr. Riley,
Mhm.
how do you do number 9?
Okay, so number 9. So, Lauren, you want to explain that to her? Sure. It's kind of a fun little thing.
Do you see where the zero is on the red? Yes.
Yeah.
So that's in line with the vertex of the blue, which means that the blue is zero.
So f of x is the derivative. Okay.
So since the red's root is directly above the minimum of the blue, that means that the red is measuring the slope of the blue.
Oh, okay.
So g of x is going to equal f prime of x. So then do the same thing for the other one. You have a root on the red. It's directly below the max of the blue. So therefore, the red, once more, is reading the slope of the blue.
So it would be g of x then?
So g of x is really f prime of x. So when you get to number 11, make sure you graph your points first. Are your siblings out of school until March 1st?
I think that was.
But they're in public school?
Yeah,
Yeah, that's what they, Montgomery County?
yeah. We go like March 1st.
Yeah, March is that's the early or something back here.
I gotta go to admissions real quick.
What's that?
I go to admissions real quick.
Yes, go ahead.
Should we do the last one? Can I see if I can do this? Thank you. Oh, no, it's okay. I can understand by like looking at it. You're good.
Dr. Wiley,
Uh-huh.
could you add Colby back in the call? He said he's been out. He got kicked out.
Gosh, yeah, I mean, look, I didn't look. Yep. Thank you. Sorry, Kobe.
It's fine. Thanks for adding me back in.
I didn't have the waiting room open, so I didn't even see you gotten in there.
Oh.
How are you doing on this? Is this going okay?
Dr. Riley, do you want us to turn this on?
Yes. All right, so has everyone in here? Got it? Okay. Did you get the sketch, the last sketch too? Excellent. Okay, anybody at home have any questions about the last few problems? So I said to post it here at the January 15th by the start of next class, which I think is not going to be till the 20th. So if it's done now, just go ahead and post it while you're thinking of it. And if you didn't post the other one before, if you want to post the completed one, I'll give you credit for having all that done. So I didn't check this on Madison's, but you wanted to talk about the second derivative too? I say do the first and second derivative test.
Okay.
Okay. Remember when you do a chart, you need to have a statement about your test results. So if you didn't post homework for today, just post your whole packet on today's date. Hey Colby, when you're doing problem number 11, you only need to have one graph. So you're only going to graph the original function, okay? good down there, Jay?
Yeah.
So I'm just about getting ready to let you guys go at home. But one thing I noticed is that as going through the homework, many people don't have statements about your sign charts. So that's a must that you have to have when you take a quiz on this. Otherwise, you're going to lose half the points on it. So be careful about making sure that you have a clear statement about a first derivative test, which includes slope, and the second derivative test will include concavity in your wording. You have no statements.
Well,
You have no statements. What are you thinking?
oh, God.
Oh my goodness.
Yeah, it was kind of a disaster for me. So,
Didn't you understand better now?
yeah, I was so super confused with the sign charts. I was getting completely wrong. Yeah, I understand.
Go ahead and practice these. This takes time. It is very confusing. You should see what our textbook has you do. This is very clear compared to our textbook. Oh, and you too, you don't have statements.
I know on the first one, I totally forgot about that part.
So on the quiz, I'll like have a box for statement, and I'll label it statement.
Yeah.
On the AP test, if you don't put a statement, they don't count the sign chart at all. So it's as if you didn't do the test.
Please listen to some afternoon announcements. Sophomores, on Tuesday for your retreat, there will be bus service. Note, however, that the morning buses will run 1 hour late. There are no buses in the middle of the day. You will need to provide your own transportation. Buses will run as scheduled at the end of the day. For the students who did not pick up their gift from the Parents Association, please stop by the front office to get your snowman soup mug. A reminder that as you are leaving from the building, please keep your social distance. No congregating. Please stand for prayer. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. My Lord, I thank you for having given me life and for having made me to know love and serve you all the days of my life and for eternity. I thank you for my faith and for the school day I am completing. I beg your pardon for my offenses and omissions of the day, and I resolve to make tomorrow a better day. Be with me as I live out the rest of this day. May I do so in your holy grace and good favor. Amen. Our Lady of Good Counsel, pray for us. In the name of the Father, the Son, and the Holy Spirit. Amen. Have a good 3-day weekend, Good Counsel.
Yes, enjoy your weekend, guys. Farewell. Okay, all my guys at home, have a good weekend.